Hi guys, welcome to my new channel, Codism. Here I'll be solving various coding problems. I'll start with a bunch of Leetcode questions. If you have any particular question you want me to solve, then feel free to put it in the comments below. Guys, please show some appreciation by liking, commenting and subscribing. Alright, so for today's problem, I'm going to choose the April challenge. Today is April 18th, 2021, and I'm picking up today's challenge to solve my first problem. So let's go through the problem, right? The problem says remove nth node from the end of list. Given the head of a linked list, remove the nth node from the end of the list and return its head. Okay, we'll come back to follow up if I feel like. So if you are given a linked list like over here 1, 2, 3, 4 and 5, and it says remove the second node from the back, right? So this is my first node from the back, this is my second node from the back. I have to remove the second node from the back, and that's what the problem is asking me to do. Now see, think about it, right? If this problem would have said remove the nth node from the beginning, it would have been a very straightforward problem. Normally we would have solved this problem in our school or college as the first thing we would normally do in linked list problems. So the first intuition that comes to mind is, how do I convert this problem to that problem, right? How do I convert this little bit of a roundabout problem to that problem? So that is what the solution that the first came to my mind. So what we are going to do is solve this problem in two steps. In the first step, what we are going to do is traverse through the list, find the size of the list, and then convert this n to, let's say, x or m, which is actually the node from the beginning, and then delete that node. As simple as that. So let's get going into that right away. All right. So we are given this method which says remove nth node from the end. So what I'm going to do is I'm going to take a variable int size equal to 0, which will capture the size. And then I'm also going to do is I'm going to take since I have to return head, I'm going to take a list node current or cur, which will actually point to head. All right. So now let's traverse through the list and say while my cur is not equal to null, I will increment my size, right? And I will increment my cur equal to cur dot next. So at the end of this while loop, my size variable will actually be the size of my list. Now let's go back on the top. So let's see over here, my size over here is 5. So my variable size will be of value 5, and I have given the n is equal to 2. So what I'm going to do is if I subtract, so this is the node, right? Now think about it. If I have to delete the node, do I have to be on the node, or do I have to be on the node before that? Yes, I have to be on the node before that. Then I will say that this node dot next is equal to this node dot next dot next. All right. So what I'm going to do, see, if I reduce n from the size, I actually land up on that node. All right. So that is the first thing I'm going to do. I'm going to say size minus equal to n. All right. Now let's take a look at a little bit of an edge case. What happens if the size n is equal to 5 over here? Then my value of size becomes 0, because now I have to eliminate my first node. So what we'll do is, this is a little trick that we normally do with linked list, where we actually put a dummy node before my first element. So what I'm going to do is I'll say list node dummy is equal to new list node. Now the value of this node doesn't matter, so I'll say -1, or I can say something else, doesn't really matter, and this node's next element will be head. Okay, so when I start with so this is where my dummy will be. Okay, and then what I'm going to do is I'm going to say now I'm going to point my current node to dummy. I'm just going to reuse the same node that I used for the size, and I'll say while size is greater than 0, because I have to traverse as many times. This is the this is the amount of my loop. I'll say cur equal to cur dot next, and then decrement size, right? So what I'm doing here is I am traversing. What did I just do? Size minus minus, sorry. So what I'm doing is I'm just traversing. So over here, my 5 minus 2 is 3, so I'm over here. I will say 1 2 3, and boom, I'm on the node. All right, so after this loop I will be at the previous node, the node which is right before the node I have to delete, right? So all I am going to say over here is cur dot next is equal to cur dot next dot next. All right, and what I'm going to return, I'm going to return dummy dot next. There you go. Hopefully I haven't made any error. All right, this looks good. Let's try to submit this. Perfecto. Let's look at more details. What does it say? It says pretty good, pretty good. I'm impressed. All right, okay, so looking back at the solution, just traversing through it one more time, what we are doing is converting a roundabout problem into a straightforward problem. In the first part, we are getting the size, reducing n from it so that it becomes a simple problem of stepping through the list and going to the node that we are going to delete. Look at the follow-up now. Follow-up says, could you do this in one pass? So how do we do this in one pass? So the first thing to notice here is that when I have to delete the second node from the end, I actually have to land at the node before that, right? The same thing that we did in the previous one. So what I am going to do is I will take a window of size n plus 1. Again, why n plus 1 is because I have to land at the node before that. So I'll take a window of size n plus 1 and keep shifting the window towards right till my right end of the window reaches the end of the list, which is null. Okay, the moment that happens, then my left end of the window will be at the node that needs to be deleted. That's as simple as that. Again, I'll repeat. I'll take a window of size n plus 1, keep moving it to the right till my right end reaches the end of the list, which is null, and at that time I'll take my left node and point its next to the next of the next. Sounds confusing, but let's do it. Okay, so what I'm going to do is, again, I'll do the same approach where I take a dummy and I'll say new list node. I can give it any value. -1 is generally what we do, and the next will point to head. Now I'll create a window, so I have to create a left list node left, which will point to dummy, and also right, which will also point to dummy. So I'll start from here, and now I have to create the window, right? So how long will be the window? So I will say window to start with will be 0. Okay, I will keep moving my right forward till my window is n plus 1. So I will say while my window is less than equal to n. What will I do? I'll keep moving my right. I'll keep moving my right is equal to right dot next, and I'll keep incrementing window plus plus. At the end of this loop, my window is created and my right is well placed. Now I will have to keep moving my window till my right reaches the end. So I'll say while right is not equal to null, and I will keep shifting the window. How do I shift window? By moving left dot next and moving right equal to right dot next. Now at this point, my left is at the node before the node that needs to be deleted. So I'll say left dot next is equal to left dot next dot next, and I'll return dummy dot next. All right, let's try to run the code. looks good. Let me try to submit it. Awesome. Alright guys, so that is how you would do it in one pass. Alright, so this is pretty good. Thanks for watching. If you have stayed till the end of this video, feel free to share, like, subscribe, and do not forget to comment if you have any questions regarding this. Alright guys, cheers, thank you, bye bye.